The question is find the Maclaurin series using the definition of Maclaurin series. Also find the associated radius of convergence. We'll talk about radius of convergence in a minute. But first of all, I want to remind you that Maclaurin series is derived through Taylor series. What was Taylor series? Taylor series for a function was written as sigma n from 0 to infinity f n at a by n factorial times x minus a power n. For Maclaurin's, it only means that a is equal to 0. Okay, so we have f of x, n approaches to from 0 to infinity, f n at 0 by n factorial times x power n, because a here is become 0. Okay, so this is what Maclaurin series formula is. To write the expansion, we need to find all fn. So I suggest you draw a table of values where n is just telling you which order you are at. 0 means that you are at no derivative. F of x is e the power negative 2x. 1 means it's the first derivative. What is the first derivative of the function? E the power negative 2x times the derivative of negative 2 will be negative 2. When you put 2, second derivative, e the power negative 2x's derivative is negative 2x times derivative of negative 2 times negative 2 will be 4. 3, third derivative, e the power negative 2x's derivative is negative 2x times negative 2 times 4 is negative 8. 4. Fourth derivative, e the power negative 2x derivative is that times negative 2 times negative 8 is 16. Then is you need to find fn at a. A is here 0. So f of 0 will be e the power negative 2 times 0 is e power 0 is 1. F prime of 0 will be negative 2 times e the power 0 negative 2. Similarly going e the power 0 always is going to be 1, so that's 4. Triple derivative at 0 will be negative 8, and the fourth derivative at 0 would be 16. Now, there seems to be a pattern here, although we can write our function, which is e the power negative 2x, using our Maclaurin series, is equal to sigma n from 0 to infinity fn. What is it coming to be? Let's note the pattern. The first, it is to the power 0, negative to the power 0, and because in the second it is negative to the power 1, it's negative to the power 2, negative to the power 3, negative to the power 4, right? So in place of this, we can write negative 2 power n in general times x power n by n fixed. So this can also be written as 0 to infinity negative 1 power n to the power n times x power n by n factorial. So that first part of the question is find the Maclaurin series. We did that. This is your answer. Now the question is also asking to find the radius of convergence. So this assume like this is the given power series. Now we need to find radius of convergence. For that we need to figure out when is the series convergent, right? I'm gonna use, remember in the last chapter we were using either ratio test or root test. Because there is a factorial in there, I'm gonna use ratio test to check when is this series convergent. Now we are only gonna focus on the already figured out series. Okay, so for the ratio test, I need to find the limit n approaches to infinity of an plus 1 by an. Limit n approaches to infinity, absolute value. An plus 1, an is this. An plus 1 would be what? Change every n to n plus 1. So negative 1 power n plus 1 times 2 the power n plus 1 times x the power n plus 1 divided by n plus 1 factorial. divided by negative 1 power n times 2 to the power n times x to the power n divided by n factorial. Now, the only thing negative in this is negative 1 to the power n. And when you take absolute value, that will cancel out because that will make it positive. So we can write limit n approaches to infinity of 2n plus 1 times xn plus 1 divided by n plus 1 factorial times the denominator fraction will flip and it will be written as n factorial by 2n times x power n. This is n plus 1 factors of 2. This is n factors of 2. Only one factor will be left. Xn divides xn plus 1. Only one factor of x will be left. Okay. So we have absolute value of x because we do not know x is positive or negative times 2 n factorial divided by n plus 1 can be expanded as n plus 1 times n factorial. So n factorial also cancels out. So what we have basically limit n approaches to infinity 2 times absolute value of x times 1 by n plus 1. So in this whole expression, only thing which is affected by n is n plus 1, which is in the denominator. So when n goes to infinity, this thing goes to infinity, the whole thing will go to 0. So whole limit should be equal to 0 actually, which is always less than 1. So because we were using ratio test here, and that limit is always less than 1, so we claim that our series which we were testing converges for all x. That means radius of convergence is equal to infinity. So let's summarize the question here. The first question was find the Maclaurin series using definition of Maclaurin series. We needed to expand this. Maclaurin series a equal to 0 was not given, but whenever it's Maclaurin, a is always 0. So we figured out derivatives of the function and using the formula we wrote the series. Then they asked us to find what is the radius of convergence. For that we need to check when it is convergent. We use ratio test to found this ratio. Limit n approaches to infinity an plus 1 by an. That came out to be 0, which is always less than 1. That means series is always convergent. Therefore, radius of convergence is infinity.